Hi everyone, thank you so much for joining us in our latest speaker series. This evening we're delighted to be joined by Ollie Walker-Jones. So Ollie left PGS in 2004 and went on to read social and political sciences at Trinity College, Cambridge. He's had various communication roles since then, including working for CBI, the Walmart Group and Rolls-Royce. Today, he's head of marketing, communications and brand at Joby Aviation, a company working to introduce air taxis to our skies. I'm really looking forward to this talk. I mean, it all sounds amazing and slightly scary, but I think Ollie's going to take us through and it sounds really great. There will be time for questions at the end, so if you do have any questions, please pop them in the Q&A function. But yeah, over to you, Ollie.
All right, I am going to share my screen, so give me 1 second whilst I make sure I do that effectively. I am Ollie, as you said, I left PGS in 2004, but I hold a very particular trophy of having actually not only attended PGS for my entire school career, but I actually worked there for a bit as well. So I did a gap year and I spent the first semester of my first term of my gap year working at the school. So I have been both in the classroom and the common room, which I think is some kind of achievement or some kind of penalty. I don't know, but I really enjoyed my time. I miss Portsmouth, and I'm really glad to be speaking to everybody here today from California. It's the middle of the morning here. I'm based in the Bay Area, so on the west coast of the US. I moved here about a year and a little bit ago to work for a company that is changing the world. I'll talk a little bit about my experience towards the end and how I ended up doing the thing that I do, but we're here to talk about air taxis. A little preview of which you can see on the screen. Before I start, I have to put this little slide on. Joby is a listed company in the US, which means it's traded on the stock exchange. So I have to put this little disclaimer up that says I'm not telling you how to trade or whether to buy or sell shares. So forgive me having to go through that bit. But then when we get into the fun stuff, look, there has for decades been conversation and talk about what flying cars might look like. These are all front covers from magazines across the 50s, the 60s, things that I read, things that our parents read, the generation before, talking about how we take to the sky. We've always wanted to do it. We've never quite managed it. I used to watch the Jetsons as a kid, a cartoon program that kind of brought to life what it might be like if we lived in a world where we could just pick up and travel in the skies. But the good news is technology has advanced really, really far since these were published. And actually, we're surprisingly closer than you think to having a vehicle that flies in the air. And I wanted to share, before we get too far down the path, a recent film that we issued about a week ago that shows the delivery of an aircraft that we have built at Joby, which we have delivered to the US Air Force at Edwards Air Force Base here in California, which is a place that has been home to a huge number of amazing feats in aerospace. They had the first supersonic boom, they had the first jet fighter, and now they have the first all-electric air taxi. And we put this film together that I wanted to show you. So there you go. That's a good indication of what it is that we're actually developing. That was our electric air taxi featured in the film. It has 5 seats. It has a pilot up front who's fully qualified, and it's all electric with a range of about 100 miles. But before we get into talking more about the aircraft, let's talk a little bit about why we're doing it. Now, this is one of my favorite charts. It basically lists the things that make us happy and the things that make us unhappy, and the amount of time that we spend doing those things. So at the top of the list, well, no surprises there. And as you work your way down, also not so many surprises. But at the bottom of the list, the thing that makes us least happy, sitting in traffic. And it turns out, as humankind, we do a huge amount of that. And this traffic gets worse as cities get busy, as our population grows, as we get more packed in more densely to the areas that we live in. We all know that traffic is a challenge, and what we wanted to do is use the third dimension to allow us to do something different. By 2045, 6 billion people will be living in cities, and the cost of congestion is actually way higher than you'd think. 4.6 billion hours a year are spent in traffic in the US alone, which for me is a really amazing statistic. And we know that it's getting worse. We know that more people are living in cities, and we know that sustainability is something that we have to care increasingly about. And, you know, sure, there are electric cars, but traffic continues to be a huge proponent of climate change and carbon emissions. So what we've developed is a system that will let you book a seat, kind of like an Uber. If you were to get an Uber today, you get your app out just like you would do with us. So we're building an aircraft, but we're going to operate it as well. So you get the Joby app out, you book a flight. We actually have a partnership with Uber that will allow you to get transported to a skyport near to where you're living. So let's say you're at PGS, you've finished your day, you want to go to the South Downs, you want to go to Shanklin on the Isle of Wight, you need to get to Southampton, maybe you have a meeting in Guildford. Any of those things, you might otherwise spend a long time traveling. We want you to be able to go straight to a vertiport, jump on an aircraft as one of the 4 passengers and fly to your destination. Our aircraft takes off vertically, so it doesn't need a runway. It will fly you forwards on the wing at speeds of up to 200 miles an hour and a range of 100 miles. It'll land vertically, but like a helicopter, and at your other end you'll be exactly where you want to be, or we will connect you to your destination using an Uber or a bicycle or whatever form of transport you fancy. And this is a good example of how it might work in New York City. So you can imagine traveling, these are 4 passengers traveling by car to a vertiport at the tip of Manhattan, and then flying using our aircraft over to JFK Airport. Today, that's a journey that takes often more than an hour, sometimes even an hour and a half, but by air, it's only going to take you 7 or 8 minutes. You can do that today using a helicopter, but it's going to be super expensive, and they're very, very noisy. And those are 2 things that we really wanted to fix. We wanted to make it cheaper. We wanted to make it quieter. And so at the bottom of the screen, you can see the partnerships that we're working with to deliver this. So Uber on the ground side, they're investors in Joby, but also Delta Airlines, also investors in Joby, and we're working to partner with them to deliver this kind of service. So as I said, we're developing the aircraft, but we're also developing an airline service. We want to operate this ourselves, and so we're developing the software that sits behind operating an airline. This is a kind of indication of what that looks like. So you can imagine software that we use to manage pilots and how they turn up, and flight paths, and the safety checks that you need to do for an aircraft, the maintenance requirements, but also the front end of the software that's required for passengers who might want to come on our app and actually book a flight and understand, just like you would do with the British Airways app today, when their flight is, where they need to go, what time it departs, the documentation they might need to fly with us. And so what we think we're trying to solve is the kind of journeys that are showing on the screen now. Today in New York City, there are 29 million trips within the 5-borough area. That's a huge number of people traveling. And actually 99%, more than 99% of those trips happen at less than 50 miles. And so what we want to do is to deliver an aircraft that allows you to make those journeys. So that's why we targeted a range of less than 100 miles with our aircraft. But we want to be able to deliver you from, just say, JFK to Manhattan, but also Manhattan out to the countryside that's nearby, that's somewhere within this perimeter. And the great thing about traveling by air is you don't need a road, and you don't need a rail, and you don't need a tunnel, and you don't need a bridge. All of the infrastructure that's expensive to do, expensive to build, and often gets congested, that's just not the case in the sky, because you're working in 3 dimensions. You're able to load the sky with many more aircraft than you are cars on a road. And as well as delivering the service in the aircraft, we're also looking at how we build a network of these vertiports across different areas. So we do a lot of work with data science to look at trips that are happening today. The darker colors here are showing where traffic, where journeys are originating, where people are traveling to, and we're working with companies like Uber to look at that data. And by analyzing that, we're able to work out where we should put the nodes of our network to generate the best possible trip opportunities. And so you could imagine in a city like Los Angeles or London or New York, delivering 6, 7, 8 different nodes that allow people to travel between them. And that will allow us to deliver thousands of journeys every single day, getting people to where they want to be sooner. And so when it came to designing an aircraft, we knew we had to solve for several things. First, we had to have payload. In other words, cargo, the things you can put on the aircraft. We knew it needed to deliver for 4 passengers and a pilot. That was the best commercial use case we could describe. We also knew it needed to meet the range or the demand of major cities. We knew it needed to go fast, and we knew it needed to blend into the soundscape of daily life and not be loud like a helicopter. Because, hey, if you want to land 50 helicopters an hour down the street from a school in a city, people are going to get up in arms and they're not going to want that to happen. So we needed to solve that. And so over the last 10 years, more than 10 years, we've developed an aircraft that can do all those things. We actually started flying full-scale aircraft around 2017, and we've flown several versions of our aircraft since then. And we've now flown more than 30,000 miles of test flights, including with a pilot on board, to get to the point that we're at. And we're targeting launching our service commercially in 2025. And this is the aircraft that we're building. These are 2 real aircraft on the apron outside the hangar that we have down in California in Marina today. And this is what we've achieved. We have 1,000 pounds of payload. That's enough for 4 average-sized people in their baggage, plus a pilot. The range is 100 miles. The speed is up to 200 miles. And the sound, which is really the very special thing, is less than or around 45 decibels when the aircraft is cruising above you. That means if you're standing on the ground and you're looking up in the sky, you're actually not going to be able to hear the aircraft go over your head. And if you're standing 100 or 150 feet away and the aircraft's taking off, you can just have a normal conversation with somebody. There isn't that really loud whop whop sound that you get from a helicopter that means that you're almost unable to talk to the person that you're with. And that was really very important to us. The thing with decibels, though, is that it's very difficult to understand exactly what they mean. And so we put together this next short film that gives you a good sense of what the aircraft actually sounds like compared to other aircraft. Now, what you'll hear is 5, I think, or maybe 6 different aircraft, all flying in the same configuration, measured from the same distance. And you can hear the difference, not only in the volume of it, but also the type of sound, the bandwidth that you'll hear. And so have a listen to this. And so what you can see from those noise charts is the bandwidth of the sound, the volume of the sound is totally different. And what I should say is, if you either struggle to hear these or you just want to go watch these films again, you can find them all on our YouTube channel. So you just go to YouTube, type Joby Aviation, you'll find all these films, and I would encourage you to go have a look and follow us in the work that we're doing. The acoustics work that we did to measure the aircraft is actually really interesting, I think, because we got to work with NASA. So NASA, the people who, most famous for putting space rockets in space, actually do a lot of work in other areas of aerospace to help understand what the future of technology may look like. And they helped us measure what the acoustic footprint of our aircraft would be. So they laid out microphones, we flew over them, and we worked with them to put these patterns of acoustic data together to show what the impact might be like on a city. And look, it's really exciting to work with a company like NASA. Just a week or 2 ago, I got to visit NASA Ames, which is one of their sites out here in California, where they have a control tower, like a control tower in an airport, and they simulate with air traffic controllers, like real people sitting there with headphones on, pretending or simulating what an airport would look like if we had lots of these aircraft coming in. So they were controlling them and trying to understand how we could add, let's say, 100 flights or 200 flights a day to an existing airport and manage what the traffic would look like. So, an amazing partner to work with and a really good indication of the sort of people that are getting excited about this sort of new technology. So we talked about the importance of alleviating congestion. We talked about the opportunity to reduce acoustics within a city and get people to their destination quicker. And the other element that we're doing is we're obviously delivering an aircraft that's fully electric. And so we're also able to help with emissions. What you can see on this chart is the grams of CO2 emissions per passenger kilometre for each form of transport. And what I'll add here is where the Joby aircraft sits. So because people won't own the aircraft, they'll just pay for a seat to travel with us, we're able to amortize the cost of the emissions for the aircraft across very many trips. So the aircraft will get used regularly, and that means that the carbon footprint or the emissions footprint of the aircraft is considerably lower than most other forms of transport, including commercial flight, which obviously uses kerosene today. Now, electric is just the first step. And we, as a company, are also looking at what comes after electric. So you can imagine batteries today are at a certain level. They will continue to improve, but we're also looking at hydrogen as a form of propulsion. And so, one of the great things about living and working in Silicon Valley and working with American tech companies is this kind of great belief and confidence they have to look at the future technologies that are coming down the path. And there's a lot of work happening to look at how we integrate hydrogen or hydrogen electric systems into the propulsion of aircraft in the future. So I mentioned a little bit about the partners, and I wanted just to touch on a couple of these. All of these people here have formal partnerships with Joby, but there are a lot of other companies working in this sector too, and they are all partnered with real companies who have real bottom lines, who invest in this technology. So often, I have conversations with people and they say, hey, look, flying cars, it's not really a thing, or it's scary, or it's never going to be something that comes to life. But I guess I'm here to tell you, actually, real serious companies investing serious money, listed on real stock exchanges, bringing technology that really could change the way we travel. Imagine if this technology existed in the UK. And by the way, we have partnerships with UK organizations too. We're talking to the CAA, that's the organization that controls the aerospace in the UK. I actually met just last week in Singapore with the chair of the UK CAA to talk about our technology. And we could really imagine network between Oxford, Cambridge, London, Milton Keynes, Portsmouth, Brighton, Bristol. All of these are great opportunities, I think, to bring networks where the current infrastructure doesn't necessarily deliver great journeys. And look, just in the last 48 hours in the UK, there's been a lot of conversation about high speed too, and whether the northern network should continue and whether it's money well invested. And the conversation is very much around the cost of the infrastructure, because it costs a huge amount of money to build a railway, to build the tunnel, the tracks, to move the earth that's required, to build the stations, to build the connections. And what if we didn't need to build that? What if the company we could build would allow us to deliver that network without the infrastructure, without the cost? That would be great. And so what I'm playing in the background here is a film of inside our facilities. I wanted to give you a sense now of what is happening day to day at our manufacturing facility in California. So we designed the aircraft, we built a few of them, we've flown lots of them, and we're now in the process of putting together a real manufacturing facility at our facility in California. We have about 1,500 people working for the company now, and a lot of those people, I'm just going to play this one again, a lot of those people are involved in actually manufacturing the aircraft. So a lot of the people we employ are engineers, people who are electrical engineers, mechanical engineers, acoustic engineers, people who are specialists in materials such as the carbon composite we build the aircraft out of, or they understand how to build motors, or they're experts in propellers. Lots and lots of people involved at a very high academic level, but also at a lower academic level, people putting together the aircraft, people who, day to day are manufacturing parts of the aircraft, some of which is relatively manual right now, a lot of which will involve robotics in the future. We also do a lot of testing of the aircraft. So, this reel will show you lots of the parts that we build being tested in various ways and geographies. Everything that we make, we have to what we call shake, bake and break. So we have to know that it'll perform really well in an aircraft. So we shake it like it would be shook in an aircraft. We bake it, we make it cold, we make it hot, we spin it, we bend it, we break it to know that the aircraft that we'll bring, this is an example of us dropping a piece of the aircraft, of firing something at one of the propellers like a bird test. And then this is a test track that we built to allow us to do some longevity testing. Everything we do has to adhere to limits set by the Federal Aviation Administration in the US to make sure it's as safe as the aircraft that we get on today. So when you go on holiday, and you jump in a Boeing 737 aircraft and you fly to Spain, those same rules are going to apply to the aircraft that we're building. We'll be selling tickets in the same way, and the FAA exists to make sure that we'll be safe in the same way. Now, I know there's an audience out there who are interested in what I do from a communications and marketing perspective, or maybe you're just interested in air taxis, but you'll forgive me, the next few slides dig into a little bit of the engineering detail, because I know there will be people who are interested in that side too. So I just wanted to touch a couple of the really neat detailed things that we're doing. So we have dual wound motors. We actually have 6 of them spread across the airframe. So electric power allows you to distribute it across the airframe. Instead of having one big rotor like a helicopter, electric allows you to spread that out. That means it's quieter, also means it's redundant. So if one of those 6 engines fails, we've got 5 more. Similarly, we're able to spread the battery packs around the aircraft. So those green blobs, each of those are battery packs that help independently control the aircraft. One of the amazing engineering feats that we've achieved is creating a motor that generates 236 kilowatts of peak power out of just 28 kilograms of motor, which includes the inverter. That's a huge amount of power to be driving out of any electric motor, and it can generate a huge amount of torque. You can see the statistics here. The torque really matters because it allows us to drive the propeller really powerfully, but really slowly. And if you do it really slowly, you get a low acoustic footprint because the tips of the propellers are moving much slower. This is a huge engineering achievement on behalf of our business and numbers that we're really proud of. We think we have the most energy dense electric motor on the planet. And we achieved that, you'd think, using a gearbox. And this is a gearbox that we had designed in 2017 that had 7 gears. But the problem with gears is they each have to be maintained, they have to be looked after, they have to be checked. There are lots of moving parts that have to be lubricated and replaced and tracked. And so we decided to deliver a motor that actually has no gears in it. And again, an amazing engineering feat to deliver that level of torque and that level of power without any gearboxes. Batteries are the other core technology where we've been able to really innovate. And so Joby is a company that's vertically integrated. We don't buy parts off the shelf. Typically, we develop everything in-house, and we do that because most of the things that we wanted for our electric aircraft didn't exist when we started building it. There just wasn't an electric motor that was powerful enough. There wasn't a battery pack that delivered the things that we wanted. And so we developed it ourselves. We took a team, many of whom came out of companies like SpaceX, companies like Tesla, who had worked on those very earliest electric vehicles and knew the technology inside out. And we had them develop battery packs for us. And what you're seeing on the screen is some of the testing work that we do. We tested hundreds of different cells and we packaged them up ourselves. And we ended up delivering a cell which delivers 288 watt hours per kilogram. And if you know, you know, and if you don't worry, that's a lot of power out of a cell, and also delivers 10,000 representative cycles. That means it can be charged up and used and charged up and used 10,000 times before you have to worry about replacing it. And at the pack level, when you take all these cells and you put them in a pack, we achieved 235 watt-hours per kilogram. Again, an amazing achievement. If you know, you know, and hey, engineers, I'm looking at you. We do a lot of work with Toyota. So big engineering company, the world's largest auto manufacturer, they actually help us. They're invested, they're our largest investor. They have helped us design parts, they help us build parts, they help us design the parts that make the parts. And they are here day to day working with us in our factory in California and in all the other places that we work. And it's amazing to work alongside a company type like Toyota. If you're an engineer and you're interested, I would encourage you to go look at some of the things that Toyota are famous for, like Lean and Six Sigma. They really set the tone. They laid the groundwork for modern engineering. They worked out how to build things as efficiently as possible using techniques like Kanban. And I would say that they are, without doubt, the builders of the highest quality, highest efficiency manufacturing that there is. And so we're really proud to be working with them. But you know, as engineers, we're super proud to have the opportunity to work with some truly amazing people from Toyota. So to bring you up to speed, we've talked a lot about like what we're building and how we're building it, but you know, kind of where are we on the journey? And so just a few months back, we launched production. So that means instead of building prototype aircraft, instead of just, you know, kind of trialing these things up and putting test pilots in them, we wanted to deliver aircraft on a production line. And so we built our first facility. We call it the mega tent. It's a long tent, basically, with a production line from beginning to end for the aircraft. And we started taking aircraft out that. And so the aircraft that you see here were aircraft built on our production line. And then just the other day, like 2 or 3 weeks ago, we went to Ohio, a state in the Midwest of the US, and we announced plans to build our first scaled manufacturing facility. That's a building that's going to be able to make up to 500 aircraft a year. And for any aerospace company, that's a huge number of aircraft to be building. We plan to bring that facility online in 2025 to support our desire to start commercial service in 2025. And then just this week on Monday, hey, I've had a busy few weeks, but on Monday of this week, we made another announcement, and that's that we have started doing pilot onboard testing. And so I wanted to play you this film that we published just on maybe even yesterday. I think this was yesterday. I'm going to play this film for you as an example of the achievement that we're making.
Marina traffic, experimental 542 Bravo Juliet will be taking runway 29 shortly. There's one side of the runway coming back to center line.
Go if your checklists are complete. You're ready for flight. TC's go. Controls 1 go. EP1 go. Batteries go. Scribe 1 go.
Scribe 2 go.
Checklists for flight confirmed. You are cleared for flight.
Copy, picking up. Air 1, 30 knots. Big detail for the top. 45, settling, expected.
All right, so that's the end of me talking about Joby. I just would like to kind of give you a sense of what it is that we're doing. It's an amazing company to work for with a great attitude, and I'm really excited about the potential for us to start service. We plan to start in the US, in cities like New York and LA in 2025, but the UK has a really great opportunity to be a host for this service too, and I could imagine in the years following 25 that you would start to see this pop up. And, having lived the first 18 years of my life in Portsmouth, I often talk to my colleagues about the opportunity for this service in a densely packed country like the UK. And I could just imagine, traveling down to, say, the seafront where there's space for a vertiport, checking in for a flight, flying up to, Haslemere or London eventually once we've built infrastructure there, maybe getting straight to a flight in Heathrow, maybe jumping on an aircraft and taking it over to the other side of the Isle of Wight. There's so many potentials for what this service could mean for people. And we're really excited to bring that service to life. Before we get to a few questions, I'm hopeful you'll have plenty. I did just want to talk a little bit about how I ended up doing this, and some of the things that I think I learned along the way. I expect there are people here who are thinking about their own careers relatively earlier, and want to kind of understand a little bit about what led me to this point. So I left PGS in 2004, worked very briefly at the school, then went up to Cambridge, studied politics. I didn't know what I wanted to study particularly, and it didn't really matter what I studied. I enjoyed it very much, but the extent to which it was relevant to my career is somewhat limited. And I have to say, when I look at people's resumes or CVs these days to hire them, I very rarely look at the specific degree, unless we're looking at people who are engineers. We're not really looking at specific degrees. We're looking at people who can show that they have proven themselves as great learners, as great achievers, as well-rounded people. I actually I worked across a whole bunch of different industries early in my career. I worked at Blackstone, which is a financial research company. I worked at Walmart, helping to persuade communities to let us build supermarkets. I worked for the CBI, the government lobbying, the business lobby organization. I worked for Rolls-Royce up in Derby on their commercial aviation side, and I really enjoyed all of those things. I enjoyed working for big companies and small companies, and I personally found a relative amount of success switching jobs early in my career. I spent 2 years, 18 months, 2 years at several companies early in my career, and I found that very useful in order to expand my horizons, to give me a range of different experiences, to allow me to step up and lead teams and take on new responsibilities. I think later in your career, it's useful to show more sticking power, to spend longer, to show some real credible achievements. But actually early in my career, I think it doesn't matter if you want to try a few different things to find the thing that really suits you. And after a few years at Rolls-Royce, I decided to switch across to startups. And people often ask me questions about what it's like to work in a startup. And I have to say, it is absolutely tremendous, and it's an amazing experience. It takes a great deal of confidence, or maybe bravery, or even idiocy occasionally, to step out of an environment. Rolls-Royce, it's a huge company. It's super well known, the crown jewel of the UK engineering landscape. And, I gave up a good pension, a good salary, lots of job confidence to go and work for a startup in Germany. I went to a company called Lilium, based in Munich, who were working on similar technology to the tech that I'm working on today. The pay was less, the security was a lot less, but the environment, the opportunity to work on something brand new, the opportunity to define your own path, to work in an organization where it has never been done before, and really you have to make it up. I built a communications function, I built a marketing function, I've done the same at Joby. That's really a very special experience, and one that will teach you a lot of things. You won't have team, you won't have resources, you won't have very much confidence, but you'll have a huge amount of opportunity to work through opportunities yourself and identify what really switches you on, and you'll grow as a human being. And I've really enjoyed that. You have to be careful that you're joining a startup that has enough runway, enough cash to survive for the period of time that you need confidence in it. And you also have to balance your salary with the equity that the company will give you. They will give you some shares of the company, and you have to be able to work through how valuable that is to you, how realistic that equity they give you will actually be worth something one day. And to some extent that's a gamble, and to some extent it's not, but it's a decision you'll have to make. Similarly, I often asked about working abroad. I've lived now in Munich, Germany, and also in California. I've also spent a lot of my career working in jobs that take me to interesting places. And I have to say, I find it very rewarding. There are huge amounts of challenges that come with moving your family. I have 2 young children to different environments, but the pain of bureaucracy that comes with it, because I've got to tell you, there's a huge amount of paperwork that comes with moving your family and your assets to different countries. But the benefits of living and working in different environments really do outweigh it. You have to be careful about tax, you have to be careful about immigration, but there are clear pathways to doing it. And I would always encourage people to take the opportunity if it exists. I thought I would touch very quickly on the pathways. Hopefully what you saw from the films that I showed about Joby, there's a huge range of opportunities to work in companies like this, from engineering to communications to sales to software to planning to project management, a huge amount of opportunities. And I found often as a younger person looking at the workforce, people often push you into doctor, lawyer, vet, and it's difficult to see the vast job opportunities there are out there. So I would encourage you, if you're looking at where your career pathway may take you, look at the huge amount of jobs there are out there. Dig into, have a look at a bigger company and search through all of the different career pathways they have advertised, because you'll be surprised. There are all sorts of jobs out there that you didn't realize exist that are really fun. And will allow you to do things you didn't think you were capable of doing. I started out thinking I wanted to do political campaigns. I ended up in PR. I've expanded into lobbying, and I've expanded into marketing. And there's a huge number of jobs in the team that I look after that you'd be surprised exist within a business. And I'd encourage you to look at them. My final words of wisdom, I don't know if they're wise, but a couple of years ago, I came across a concept of ikigai, which is a Japanese concept that allows you to make decisions about the things that you should care about. And I found this powerful, so I thought I'd share it. There are 4, this is like a super complicated Venn diagram, but basically 4 things that could matter, what you're good at, what you love, what the world needs, and what you can be paid for. These are things you should try and solve for. And if you can solve for all of those, eventually you get to this kind of center ground, which is happiness, that allows you to have a profession, a vocation, a passion, and a mission. And I'd encourage you to have a look at that. I've waffled probably for plenty of time now here. I think I promised I would speak for 40 minutes, and I think I have. So I would love to answer any questions that anybody has, and hopefully I've inspired you all to take to the skies with us in the years ahead. Thank you.
Thank you so much, Ollie. That was really fascinating, and I felt really lucky. I feel like you were giving us proper exclusive insight into what's happening at Joby, because this is I don't know about anyone else, but I haven't known much about this, so it was really lucky to see all that kind of content you had, all the recent footage. So yeah, amazing progress. So thank you so much. And those were wise words. I took a little screenshot on my phone of that Ikigai diagram. I love stuff like that, so thank you. Also really enjoyed what you said about how careers aren't always linear, and it's good just to try different things and broaden your skills, and things might not work out the way that you intended, but it can work out better. So I think those are really wise words, especially to our younger alumni and to our current pupils. I think that can really resonate. We've got a few questions, so I'm going to kick off. You talked about vertiports and where people can land. Can you only land at a vertiport, and if so, how many you're going to need to have? Could I just go anywhere I wanted in an air taxi, or am I going to be limited by the vertiports?
So it's a great question. You will certainly, in the early years of service, you will need to land somewhere where there's a concrete pad, where there's a charger, and where there are facilities to process passengers. And typically that means that you'll be landing somewhere that is an existing vertiport, like a specific destination that you will have chosen to land at. Now, you don't need much. You need a concrete pad that's about the size of a helipad and a porta cabin to process people, and a high voltage charging cable, although actually we can do some journeys where you land, and if it's only a short journey you can take off again. It's obvious that in the first instance there are lots of helipads that exist already, so we can go and use them. There are airports where we can land and we can use them, but actually the plan is that we would be seeing these built in different locations. So you can imagine Gunwharf Quays, they want people to come, they want people to travel to them, they want interesting experiences. Nothing stopping them using a little bit of the land they have to build something. And so, you know, the sports stadiums, shopping malls, airports, transport connection points. You could put one at the Hard so that people could connect to the ferries. You could put one in the international ferry terminal. There's all sorts of places we could expect them to come. They don't exist yet, but equally they're only going to take 12, 18 months to build, and we're hopeful that they will sprout up everywhere.
Great. And how long would it take to charge each one?
Oh, yeah, you know, I didn't talk about that. So much like a Tesla, they're designed to use rapid charging. So you need a great deal, you need a lot of electricity to do that and a high voltage. But what you get in return is fast charging. And also the battery packs are designed to allow that to happen. So we plan that during an average journey, and we expect the average journey to be about 25 miles. So on a 25-mile journey, you actually don't use very much of the battery. And so the plan is that in the time taken so the aircraft lands, and you need to get your 4 passengers off the aircraft. You need to make sure it's clean and tidy. The pilot needs to check everything in the aircraft. You need to put 4 more people on and get ready for takeoff. We would plan to recharge the aircraft in the time taken to turn the aircraft around. So actually really not very much time at all. You're talking single-digit minutes at that point. For longer journeys, it will take a little bit longer, but we're talking still minutes rather than hours.
Wow, that's very impressive. We got a question from someone in the audience. So great presentation. Joby is focused on urban centres. Is there potential for rural links? So this particular member is interested in the Philippines, a country of 7,000 islands, many of which have small airfields. Yeah,
it's a really cool question. So we talk a lot about cities because there's an obvious use case today. Partly because the infrastructure exists and partly because the congestion is bad and there's a density of population that allows us to support a service. But I actually think there's real true value in looking beyond cities into regions. So if you can imagine regional communities where there isn't great density, you can't justify building a high-speed rail network. You often can't justify building a junction of a highway or even in some cases a main road because there isn't enough use for it. So absolutely supporting those communities. You know, the cost of building a landing pad could be as little as $500,000 to allow you to build something. And so we could provide that kind of connectivity and, on a more scheduled basis. So, hey, look, there are 2 flights a day, but they go into the main town center or city center. Absolutely. Connections between islands, another great example. So, we've looked at Hawaii, we've looked at Jeju Island in Korea. I often think of the Maldives as another good example, and the Philippines is great as well, of where there are lots and lots of little islands that you can't build bridges between. You can build. We can have boat services between them, but you can't build a runway on each of them. And so actually a vertical lift allows you to solve a lot of those problems. And so that use case is, I think, going to be really interesting. There is also, in the longer term, the opportunity that this could become something that's used for a humanitarian purpose too. So where, where there's a flood or a famine or somewhere gets disconnected for some reason, you can bring this aircraft in. You don't need a runway, and that's the really important bit. You can get aid to people. Or people to people as quickly as possible without the need to travel across the ground, which may be challenging. Yeah, that's really transformational, isn't it? Think about all the broader uses for it. Thinking about your role as head of marketing, what are the kind of, some of this might be a bit obvious, what are the kind of dream things about it that make it a marketing dream, and then what are the challenges as head of marketing? Like so I'll start with the positive, like, who doesn't want to talk about things that fly? Everyone loves flying. It's really exciting. It kind of captures a childhood excitement in everybody. And if you consider what this aircraft is going to look like, most people don't get to fly in a helicopter because it's expensive. The idea of lifting vertically and flying not very high above a city is really appealing because the views you're going to get are going to be incredible. We have really, really big windows and you're only going to be a couple thousand feet off the ground. So it's going to be magical. Also, Uber was really transformational in terms of like how we travel and how we think about travel, and being there at the forefront of a company an industry that's going to do that and achieve that is something that I get really excited about. But for all the positives, I actually chose to take this role because I thought it was probably the hardest marketing comms job there could ever be, because we're trying to build 3 companies really. We're trying to build Boeing, which builds aircraft. We're trying to build British Airways, which operates the aircraft, and we're trying to build Heathrow because we want to do the infrastructure as well. And so, we've got a really, really big business that's super capital intensive. It's very hard to build aircraft and certify them because they're highly regulated. And let's be honest, there will be, for every person who's excited about flying, there'll be somebody who says, I don't want this flying over my house, over my school, over my business. I don't think it's safe. I don't want it. It's noisy, even if it's not. And so there's a lot of challenges around how you will make this publicly acceptable. And then, from a much higher kind of meta level, as a professional challenge, we're introducing a company that no one's ever heard of, a technology that no one's ever heard of, a sector that no one's heard of, and a form of transport that no one's ever heard of, kind of simultaneously. So it's not like, when Tesla introduced the electric car, the car already existed. We knew what that was. And when Apple introduced the iPhone, we already knew what a phone was. So we had a frame of reference. And sure, they made it exciting. They had to introduce, but we already knew what it was. Whereas, this really doesn't exist. And so we're having to build everything from the ground up. And we're doing it with not very many resources. So it's challenging on a few fronts.
A good challenge. And yeah, like, how do you kind of build that trust and reputation is something that you said is on so many unknowns. And you mentioned a couple of things I just wanted to pick up on. So, thinking about how high they will fly and flying over things, are there any air traffic control implications?
Yeah, so for those people who watch this who are pilots, they will know that actually the vast majority of airspace is uncontrolled. So you go in your little 2-seater airplane and you fly around the skies over the UK or skies of the US, and unless you get close to something important like Heathrow Airport, the vast majority of the airspace is not controlled. You are in control of where you go. You're in control of making sure you don't bump into other aircraft, and you may have some fancy radar equipment. You may have somebody looking out for you from the ground who, from an air traffic controller, who tells you that there are other aircraft, but not necessarily. So the vast majority of the airspace that we fly in, we'll be able to do that. We'll just go up there and we'll fly. However, we will also want to fly into airspace that is controlled. So, around a busy airport, there are channels where the aircraft have to come in, and there are people who sit there making sure they're sequenced effectively. And so we will have to participate in that to some extent. And so making sure that the people who do that are well resourced enough to add in all of our aircraft as well is one challenge. And we're relatively confident that's going to be fine. It's just like dealing with a helicopter today. So as long as the resources there, will be fine. But in the long term, if you kind of scooch forward 10 years or 15 years, we could imagine a world where there are lots and lots and lots of these flying around. And then we may have to control the airspace a little better than we do, because there can just be more things in the air. And at that point, we're looking at modernization of air traffic control. And that gets exciting because it stops being about humans and bits of paper and TV screens, and it starts being digitized and it starts being automated. And so, the future of air traffic control, actually really interesting subtopic of how you put that system together in such a way that allows the growth of air control. But it's a pretty deep topic for anyone who wants to get into it.
Do you think there will be pilotless aircraft, as we're seeing, driverless cars on Earth?
Yeah, absolutely. So in many ways, it will surprise you to know that it's easier to have autonomous aircraft than autonomous cars, because there are fewer things to bump into in the air. The air is relatively open, and airspace is, at least the landing, and is relatively controlled where you do it. So there are companies out there, look them up. A company like Whisk, also based just down the road from here in Silicon Valley, who are doing just autonomous aircraft, and we are certainly interested in developing the technology. We own a company called INRAS based out of Austria that are looking at the radar technology, or the LiDAR radar technology required to allow autonomous flight to happen. So yes. It's a while away. Like, it's not going to be next year. It's not going to be 2026. It's a while away. But I often think about it in terms of my own mother. I'm like, would she get in an air taxi today? maybe if I persuaded her, but I bet my bottom dollar she'll not get in one that doesn't have a pilot on board. So we're going to have to go through that phase first to get people comfortable. Then we can
you've got to walk before you can run.
I've got to tell you, in San Francisco the other day, I got in my first autonomous taxi. So a company called Waymo driving, and there are other companies like Cruise. They're driving autonomous taxis today around San Francisco. You can just jump, you can book it on your phone, have a look. The car will come to you. You enter the code, you scan something on the car, the door opens, you get in, it drives you to your destination, you pay your fee. There's nobody in the car with you. I mean, it's transformational. It's kind of weird, but also really cool.
And just a bit scary.
They're very cautious at the moment. The car, it feels cautious when you're in it.
Cool. Okay, so a couple of last questions. If anyone else has any other questions, please put them in the Q&A. How much would a journey set me back? So have you done any costings?
Yeah, so we plan to. The end mission is that it is as affordable as possible, as accessible as possible, and as competitive as possible with existing ground transport. It's going to start a little bit more expensive naturally, but the price will come down. We think it's likely to start around about the price of an Uber Black. So if you get the most expensive version of Uber today, it's relatively pricey. That's kind of where we anticipate it starting, but the idea is that it will come down over time to kind of like the Uber X that you would get today. So, long-term goal is $2 or $3 per passenger mile, which means, a journey that lasts you 10 minutes is you can get from, let's say, like Heathrow to downtown London for maybe $100. I was going to say $100, so like 80, 85 quid.
Nice. Cool. And then finally, last question, Ollie. What's next for you? Because this sounds like it's on our, it's right on the doorstep. We're almost there. Have you thought about what your next challenge is going to be?
Yeah, I'm pretty invested in this right now. I would love to see this business start commercial service and grow. And I think, as we start to grow it into cities and communities around the world, we're talking to Korea, to Japan, to Dubai, to the UK. I would love to help this company grow to the point where everybody dials into this call because they have heard of it, they know it, and they're excited about it. Today we're still in like the introductory phase. One day we'd love to be a household name. There are many things that may get in our way, but I'm confident we'll get there. And I hope to be able to come back and do this talk again when people are like, oh wow, cool, yeah, I know that, like Airbnb, like Uber, that kind of level of knowledge. That's where I'd like to take it. I hope very desperately to get a green card that allows me to stay in the US and to work for other companies. But I'm very into startups that are disrupting, particularly travel. So I expect me to be around here. If I could pick one other job, I'd go work for like SpaceX or Blue Origin, one of the rocket space companies.
Amazing. Thank you so much for sharing your story with us, Ollie. It truly was fascinating, and some really great nuggets of advice there for people thinking about their own career paths. And I'm sure Joby Aviation and air taxis will be just as common as Airbnb and Uber in very near future. So thank you so much for joining us.
You're welcome. I would just say one final thing, which is if you're interested in the company, check it out online. If you're interested in Joby specifically, hit me up on LinkedIn. If I can help connect you to anybody that I've ever known along the way, either at startups in Europe or in the UK or engineering jobs in the UK, I'm always happy to help people that we're connected to. So don't be shy.
Thank you so much. Bye, everyone.
Bye-bye.